All right, so problem 3 came from 2006 Form B and it's question 2. Previously, we've been working with one proportion problems. Now we're working with a two proportion. So a large company has two shifts, a day shift and a night shift. Parts produced by the shifts must meet the same specifications. The manager of the company believes that there is a difference in the proportion of parts produced within the specifications by the two shifts. That word difference is a key phrase. To investigate this belief, random samples, they put an S on it, that means I have more than one, of parts that were produced on each of these shifts were selected. For the day shift, 188 of its 200 selected parts met specifications. And then for the night shift, 180 of its 200 parts met specifications. Use a 96% confidence interval to estimate the difference in proportion of parts produced within specifications by the two shifts. So you do not need to write this, but I know that I have two proportions. And if I were writing a null hypothesis, that'd be they were equal. The alternative would be saying, hey, there's a difference, so not equal. All right? Not required, but sometimes it helps you out to do that, even though we're working with a confidence interval. And that's the other thing, is they almost always tell you to work with, when they tell you, when they want an interval, they almost always tell you they want an interval. They may not tell you if it's 95 or 96 or 97. You may get to choose that, and usually you would choose 95, but they almost always tell you that it's an interval, so that's a good thing. So we always have to define our parameter, and since we have two parameters, two proportions, we have to define both of them. P is the true population proportion of parts that met specifications from the day shift. And while we're here, let's go ahead and talk about P hat. Well, from the day shift, we know that there was 188 of the 200 that met specification. P2 is the true population proportion of parts that meet specifications from the night shift. So P hat 1, P hat 2, and in this case, we have 180 out of 200, and I just got that from right there, okay? So I have to do the conditions for both of them. You can somewhat combine the conditions, but you have to make sure that you address it for both. So random samples of 200 for both shifts is given, all right? Independence, reasonable to assume that one shift's proportion of defects does not affect that of the other shift, or I can actually somewhat combine these. And if I say, hey, you know what, we have two independent random samples of 200, I can combine these two conditions together, and I'll be taken care of. That would take care of it as long I can combine them like that. If you, but only in the case of independence can you combine with the random. And that's only the case for two samples. All right. N is less than 10% of the population, so 200 divided by 0.1 is 2,000. Both samples were 200, so this takes care of both of them. Reasonable to assume that there are more than 2,000 parts made during each shift. In other words, I need to make sure that it wasn't made, it's made during the night shift and the day shift. So I made sure I used the word each to show that I was addressing both day and night shifts. Then I need to make sure that each sample is large enough. Well, they tell me that I had 188 good parts in the daytime, which means I had 12 bad parts in the daytime. At nighttime, I had 100, excuse me, I don't think it was 108, it was 180 good parts at night. That means I had 20 bad parts at night. Since all four of them met the criteria, both samples are large enough to use a normal approximation. All right, so the confidence interval formula is P hat, the first one minus the second one. Please notice that we're using P hat as part of our standard error. Why? We're making an estimate for the proportion. We don't have a claim. Since we don't have a claim, we have to use P hat, and you'll always use P hat on confidence intervals. If it's as long as you're working with proportions, this will always be a P hat down here, okay? So what is p hat 1? Well, we already wrote it up above. We said it's 188 over 200, and that's 0.94. P hat 2 is 180 over 200 is 0.9. I went ahead and solved Q there. I didn't have to, but I did. That way, when I plugged it into the formula, I get something like this. But I need to go ahead and calculate my Z star. Z star is second VAR's inverse norm, 1 minus 0.96 divided by 2. And we end up with 2.0537. All right, and now we're ready to run, actually run the test or the interval. So stats test, and I have to scroll way down to 2 proportion Z interval. All right, 188 good parts out of 200 for the day shift, 180 good parts out of 200 for the night shift, confidence level of 0.96. And I went through that way too fast, hit the button too many times. And here we go. So we have negative 0.0156 as our interval to all the way to 0.09557. So that's our interval. Now, one thing we should notice is that our interval contains 0, and we'll need to address that in a little bit. So we are 96% confident the true proportion, the true population proportion for the difference in parts that meet specification day shift minus night shift lies within the interval between, lies within the interval here. This should be scratched out, between sorry about that, lies within that interval. Okay, so based on this confidence interval, do you think that the difference in proportions of parts produced with specifications by the shifts is significantly different from 0? Justify your answer. Well, the answer is no. 0 lies in the interval, so 0 represents no difference between the shifts. Don't need to say that. That was my information for you. And because 0 lies within the 96% confidence interval, we cannot claim that the proportion of parts that meet specification differs between the two shifts. So while we can sit there and look at the numbers and go, you know what? The night shift only had 180 good parts, and the day shift had 188. So there is a difference, but it's not statistically significant. All right? That could happen by random chance alone if there was no difference.